record that. Yeah, so quadratic function could have either a minimum point or a maximum point. And it also has the property that it will have a line of symmetry. In this case is the y-axis as a line of symmetry. And you basically, if you flip this over to the other side, they will match, kind of like a mirror image. And if you want to go over that, they will this side and that side will if you fold one side to the other, you'll see perfect match. So we call that symmetry. I have a line of symmetry, or axis of symmetry, and but with different kind of quadratic functions, you are going to have a different point. It could be like that. It could be like that, or it could be something just go like that. So they're all quadratic. And the minimum and maximum point is called vertex. So a quadratic function has a vertex point. We know that. Vertex, just one vertex point. And also have a axis of symmetry. Okay. And where is the vertex point? Where is axis symmetry? Is depends on what kind of function is. So normally the quadratic function has this form, is y equals to, say, 3x squared plus 2x minus 5. This we see this kind of things before. If we write like this is our quadratic equation. And we learned how to solve in this. So the form for the function is, you want to be more general, will be y equal to ax squared plus bx plus y. C. Now we have one variable x, and we also have one variable y. Now this function, since on the right-hand side only have one variable, normally it's called one variable function. Now some functions could have more than one variable. But for the quadratic function, we have one variable. We always have this term. Okay, so in this case, this x cannot be 0. It can be negative, can be positive, but cannot be 0. And this can be 0, and this can be 0. So there could be any real number, b and c. So the only thing they cannot be is this coefficient. This is called the leading coefficient, because this term y squared is the highest degree in this function. And so the leading coefficient cannot be 0. Other than that, they can be any real number. So it depends on what the number they have, then we'll have different shapes of the graph. So this is something we call concave up, and this is called concave down. And we can see why we have those, what determines is going up or going down. And we could looking at a simple sort of way looking at is y equal to x squared. We did that early on. This is going like that. Now, if y is negative x squared, so we know this is a is 1. Here the a is negative 1. Then it's actually going down like that. So when we have a function like ax squared plus bx plus c, for example, if we have, say, y equals 3x squared minus 5x plus 1, because this one is the positive, so it has to be going like this. And if a function like say y equal to negative 2/3 x squared plus 5x plus 10, because this term is negative, so it's going to be done like this. So that's first thing we look at the coefficient. If this is positive, we got concave up. If it's negative, it's concave down. Okay, are we good here?
I believe so.
Yep. So if you want to kind of remember this, one way to remember is that this is more like kind of smiling, it's kind of like smiling. This is kind of sad, kind of, I guess will be the lips. So the positive is good, negative, that's sad. So you get this frowning face. Another we can looking at for is just checking these two functions. And if you want to graph it, this one you get like this. If you want to graph that, it's going down. So positive going up, concave up, negative, concave down. Or positive is up, or negative is down. Good. Okay, knowing that, then we need to figure out where can we find the vertex point. So, and that help us to figure out the develop vertex formula. Okay, so we talk about we have this face ax squared plus bx plus c, and that's called the standard form. And we also have another form. It's actually like this, x minus h squared plus k. This is called vertex form. Now, the reason we call this a vertex form, because here in the equation, that gives us the vertex. Because h comma k, that's the vertex. Well, how do we know that? You can see that this number is a square, so x minus h squared. That is always greater than or equal to 0. So therefore, when x equal to h, if a is positive, then we go that is positive. If x, so x equal to h, then this part is 0. And if x is not equal to h, then it's not 0. So in this case, the h, comma h, that's our vertex. Now, when x equal to h, so this thing is 0, then y equals to k. So this one, h comma k, is our vertex. I'll give you an example here. When we have, say, y equals to, say, 3x minus 2 squared plus 5, then we know that it's going to be like this, and this point is 2 comma 5, because if x is not 2, it's always bigger than 0, so it's always bigger than this point. And 5 is a minimum, because if this one equal to 0, we got 5. If x minus 2, if x is not equal to 2, then this part is always positive, and plus 5 always bigger than 5. So this is our vertex point. Yep, are we good here? Okay, and I'm going to have you just type the answer. If I give you the vertex form, and you just tell me the vertex point. So y equals to, say, 2/3 x minus 3 squared minus 2. So what is our vertex point?
Hey, sorry, I just got back. I had to do something real quick. What are we working on?
Yeah, what? Well, to find the vertex point when
Okay,
we function.
let me look it up real quick.
Sorry, I'm confused.
Oh yeah, isn't it the equation like y equals ax2 plus bx plus c or something?
Yes, it's something. It's related. Okay, it's not that, but it's we're talking about quadratic functions. Uh, well, when you have something like this, where is we know that this part,
Oh, right. I remember now.
this part, the smallest number we can get from this part, then is when x equal to 3. So that is the x coordinate for the vertex. But what happened to y coordinate for the vertex point is when this part is 0, y is -2. So that's y coordinate is -2. So the vertex point actually is 3 comma -2. Good. Okay, I'll give you another. So y is equal to
No,
4
math class.
x minus
No, I don't work on Wednesdays.
2 squared plus 7. So what is the vertex point? Good job, Tammy. Yeah. So our form is this, y equal to a x minus h squared plus k. That's the form. So therefore, our vertex point is, we write as this, 2, we said h comma k. Okay,
Okay, so the h and k are the coordinates.
that's the point of the vertex.
Okay.
Mhm. So h is the x coordinate and k is the y coordinate. Yeah,
Oh, okay. Okay.
Bob Morgan.
So yeah, we have to calculate this to find the vertex.
Well, we don't have to calculate because it's given. It's there.
Well, yeah, we know the x and the y, but we have to use the equation above to find the vertex point.
Oh, no, well, we just not, we have the number right there.
Okay.
So this basically give us the template. So you just can follow this template. In this case, for this one, what's our h? What's our k?
So is the base 7, right? Is the base 7?
You mean the y coordinate?
Yeah,
Yeah, y coordinate is 7.
and I can only guess that the x is the x that 4 is the x coordinate. Right?
You see how did these two match? This is basically is our template. Okay, 4 is our A, 2 is our H,
Okay.
7 is our K for this case. So therefore, the point is 2, comma 7.
Okay.
Good?
Okay.
Okay, and you can see that the reason this is 2 comma 7, if you plug x equal to 2, this part is 0, then y has to be 7, right? So we know this point is is a solution to this equation. That means this point, when you graph this function, this point is on the graph, on the line. Okay, I'm going to another one. Y is equal to negative 3x minus 7 squared minus 2. Let's see what you got there.
I'm not really following, so I'll just observe.
Well, just look at the template. This is a template. And see which is which. What is our H? What is our K? So H comma K, that's our
H is 7, and then K is 2, or
what?
negative 2.
Right. Good job,
So that would be
Oregon. Good job, Jet. Right. Good job, Elsa. We good? So you can see that x minus 7, if we compare with x minus h, then our h is 7. Looking at the k, this is plus k. Minus 2 is plus negative 2. So therefore, our k is negative 2. Then our vertex point then will be 7, comma, negative 2. So that will be our vertex point.
Wait, is that all I had to do?
Good?
Is that all I had to do? Or I thought I had to solve it somehow.
No, let's just find out what's the vertex point.
Oh, okay.
It's giving you already. I just
That's simple. So sorry about that.
no problem. No problem. Okay. So now we actually get something bit interesting is to figure out um, the vertex point if I got something instead of this form, because this form is pretty easy. It's to give you the point. That's why it's called the vertex form. We have the vertical point there. But a lot of times we got this form. Then, so how do we figure out if we give this, say for example, y is equal to 2x squared plus 3x minus 5. How do we figure that out? Well, we have to do some algebra here. What we know is even though we have the two different forms, this one is called standard. This one is called the vertex form. But we're talking about the same function. That means we're going to have the same graph. So if you give the same x, we should have same y. It's just two different ways of saying the same thing. So therefore, we have equation is we have a x minus h squared plus k equals to ax squared plus bx plus c. right? Because we are the same on the same line. So this y and that y will always equal if this x and that x are the same. Good? Are we good on this one? All right. Jed? Okay. Usher?
I think so.
Okay. So once we have that, then we can do some algebra. Well, on this side, what we see A, then this one we can expand it. This is basically x minus h times x minus h. That give us x times x, x squared. That is negative hx minus hx, then plus h squared. So we have x squared, and this give us negative 2hx plus h squared, then plus k. That equals to ax squared plus bx plus c. So now we're going to plot separate those. So we got ax squared minus 2ahx plus a h squared plus k equals to ax squared plus bx plus c. So now you can see that this term and that term are the same, so we can cancel. So it ends up with this 2ahx plus ah squared plus k. This side is bx plus c. Okay, one thing we know that this equation is always true, no matter what x value. So therefore, we can set x equal to 0. That means that term disappear, that term disappears. So we got a h squared plus k equal to c. And now, because this part is equal to this part, then what that means, we have, let me see if I have some room, which means that then negative 2ahx has to equal to bx. Yeah, are we here so far?
I think so.
Yeah,
It's a bit confusing, just a lot of letters and numbers.
right. And so that's the heart of when we're doing algebra. We are manipulating letters, but we follow the same set of rules. Yes,
Mhm.
we all started from here. So that's basically when we do math, it's all about logic reasoning. We start with here. The reason this is true is because this function and that function, we are talking about the same function. They're just expressing a different way. Now, if this is true, then this have to be true, right? We are good here, Usher?
A minus a squared plus
Um,
a. Okay, I think so. A squared
good.
a times x.
So basically, I just expand this term, right?
Okay, yeah.
And
Okay, yeah.
then
So that's the simplified for okay.
I'm going to multiply back in the a. So we got ax squared minus 8 times that minus
Okay,
2x.
I
Then
see.
a times h squared, then plus k, right?
Okay,
And now we
yeah. I
can
think I
see that.
understand. That makes sense.
Okay, now we can see that ax squared and ax squared, they are the same. So we can cancel that. Okay.
Mm-hmm.
And then we got to this part. So basically, we're talking about logic concept progression. We start from here, then if this is true, then this has to be true. So that's what we call logic. One thing leads to another. And on this equation, x can be any value. So therefore, we can set x to 0, then we end up with this. Okay? Are we okay this on this step? Yes? Get?
Hey, so I see we kind of jump from neg from -2 ahx plus ah squared plus k equals bx plus c to ah squared plus k equals c. How did that happen?
Well, if we set x equal to 0, what happens?
Everything multiplied by that equals 0.
Well, this part is 0, so disappear, and this part is
How?
0, disappear. What we end
How?
up with is this.
Okay, so where do we get the x from 0? Where do we get the x equals 0 from?
Well, x can be any value. This is variable.
So what would we do if it was a 2?
What's that?
So what would we do if it was like a 2?
Well, if it's 2, then we won't get to this part.
So why does it equal 0 in this case?
Well, if I have x equals 0, then I can make this part disappear, and I can make this part disappear.
Okay, so it's just 0 for convenience.
Yep.
Okay, cool. I didn't know you could do that.
Well, that's how we do it, playing with symbols. Good.
Okay, yeah, that makes complete sense. Thanks for explaining that.
Well, the reason we can set x to 0 is because we said this equals the left equal to the right, right?
Yeah, definitely.
And
About that.
and for this to be true, x can be any value. So
Mhm.
therefore, I just pick x to 0, then I can get to this part. Good.
Yep.
Okay.
Thanks so much for explaining.
No problem. And because this and that are equal, so therefore this has to equal to that, right?
Yeah.
Now we're going to have another trick. For this equation to be true, x can be anything. So I'm just set x equal to 1. So therefore I got minus 2ah equals to b. Good?
Yep.
Now we are trying to find h, right? That's all that matters. We're starting from this one. We're trying to find our h. So we divide by 2a on both sides. Then our h is negative b over 2a. Good. That's the first formula we got. Find the h. Are we okay on this one?
Hang on, give me a second.
Okay. Yes, Jet.
Yeah, just copying down the formula. -2a h is equal to -b 2a. Okay.
So
Thank you.
that's our the first half of the we call the vertex formula. So now we're going to see what we're going to do for the k. We will find the h. We need to find k. Well, remember we had this early on. So we got a h squared plus k equal to c. Now we know h now. Here we had formula, so we plug that in. So a minus b over 2a squared plus k equals to c. And same thing, we're going to work, just do some algebra. Then, so the power algebra is because we can manipulate with the symbols, with the letters. So this part is a, we know negative squared is positive, so we got b squared over 4a squared and plus k equals to c. Yep, are we good here?
Yes.
Yes, Jet,
Yes.
good? Okay, now we can see that this A and this A squared, we can take out 1A, right? So we got B squared over 4A plus K equal to C, right? Are we good on this one? Yes?
Just
Yeah.
a second. It's just gonna be A's cross out, A squared crosses out. It's the B squared over 4A.
Good.
4A plus K is equal to C. Cool.
Okay, so now we're going to move this over because I want to find K. So the K then will be C minus B squared over 4A, right? We good?
Okay, so that formula means that's how you arrive at that formula.
Yeah, we just moved it to the other
C
side.
B squared 4A. Aha, cool.
Good?
Very interesting.
Yep. Okay, once we have that, we want to put them together. That means I have to have the same denominator, so I can change C as 4AC over 4A, right? 4A and 4A cancel, we got C. The reason we put down there is so we can put those two together. B squared over 4A. So therefore, what we got here is this, 4AC minus B squared over 4A. So now that's our K. Good? Yep.
Hang on.
So this is called a vertex formula, is that we can find the vertex based on the standard form. So now I'm going to write it on the top,
This is Vertex formula.
not vertex. This is a vertex formula.
So the K equals 4AC minus B squared over 4A. That's the Vertex formula.
Yeah. So we have H, that's the X coordinate, the vertex point is B over 2A. Then we have K equal to 4AC minus B squared over 4A. Good. So I write down here. Now I'm going to use that if we got a quadratic function. So let's see. For example, we have one. If we got, say, y equals 2x squared plus 4x minus, say, 3. Okay, we know our A is 2, B is 4, our C is -3. We're going to use that formula. So H is equal to minus B over 2A. B is 4. 2, A is 2. So that gives us -4 over 4, -1.
2 over 2. Let's do it. -4 over 4. So that'd be equal to -1. Okay.
So we got H. We got 4. Our A is 2. Our C is -3. We got that. That's our 4AC. Minus B squared. B is 4. So B squared 4 squared. The bottom is 4A. 4 times 2. So the top will give us 4 times 2, 8. 8 minus times -3. That's -24. And 4 squared is 16. And that's 8. So what we have here is, trying to do here,
That'd be 8 over 8.
negative, this what? We got 40, right? Over A,
40.
right? -24 minus 16, that's -40. And divide by 8, that gives us -5. So therefore, we found our vertex point is at -1 and -5. Because our H, we got that. Our K is this. Yep.
Yes.
Are we good here?
Aye.
Okay. So I'm going to give example and using this, I'll keep the formula there and you'll calculate the vertex point.
Sounds good.
Okay. Y is x squared minus 3x plus 4. See what you get. Yep. I'll be right back.
Three over 2 times A. 2. Okay. And then K is equal to C minus B squared over 4A.
I might be the only one still not getting this.
So we have C 4 minus 3 squared over 4 times 4. Okay. Minus 16. Wait. Don't even get this correct.
Okay.
3 over 2,
Go back.
comma.
I'm sorry, I'm still confused.
If it makes you feel better, I'm always confused. So
Well, you can see that what is our A? Our A is 1, our B is -3, our C is 4. So what about plugging in the formula?
how do we know that our A is 1?
Well, A has to go with this.
Yeah.
That's 1, right?
That's true. Yeah.
X over here, just 1x. Yeah. Yes.
Wait, what are we supposed to do again? What are we
Fine.
supposed to?
Okay. Good job, can we?
I'm gonna be honest. I'm lost. I don't know where to start. So
Well, you can see that H is what?
A is so.
H
Wait. H
minus B
is
over 2A. We'll just plug in.
okay.
You know what A is. You know what B is.
Oh, I thought that was a 6 for some reason. Never mind. So that would be -3 over what? 2, 1. 2 times 4, that'd be 2. So Wait, would H be 1/3? I'm confused.
What? B is what?
B is -3.
Okay, R2 times 1.
Mm-hmm.
Negative times negative is positive, and 2 times 1 is 2. So H is 3 seconds.
Okay.
Yeah, just plug in the number.
Minus-
I see. Okay. Hmm.
So to find the K, it says 4 times AC plus or minus B squared.
Mm-hmm.
So how do I write that out? Do I just multiply them all? I don't know.
4AC, yeah, 4 times C, A times C.
So A times C, that would be 4, and then 4 times AC, that would be 8 or 16, right?
Yep.
Okay, so 16 minus B squared. B squared is -9.
Nope, negative square is always positive.
Oh, right. So that would just be 9. So
Yeah.
16 minus 9. Sorry, I didn't realize it that simple. So
Yep, it is. Just plug in the number. The proving part is a little bit harder, but using it is actually pretty straightforward.
wait, that means A is just 2 negative. So H is -2/3 or 3 seconds, and then K is 5/4.
Well, K is what? We know 4 times A is 1. C is 4 minus B squared, -3 squared, then 4 times 1. So what we got here is 4 times 1 times 4 is 16. Then -3 squared is 9. And over 4. Well, -16 minus 9 is 7. So 7.
Oh, yeah.
So we got
I meant 7, not 5.
3 over 2 and 7. Oh,
Over 4.
over. What's going on here? Okay, over 4. And that's what we have.
Okay. Yeah, I got it now.
7/4. How did that?
I don't need my notebook.
Okay.
How in the world do you get that? Okay, let's see. So the proper formula is K is 2
What's that?
minus. How'd you get the -3 over minus? How'd you do that?
Which one?
So I'm looking at the answer for K.
Yeah.
So you did 4.
So
Great.
near the bottom, there's the K, and above, there's like the little graph on how it is done. Yeah.
Yeah, I just saw that. Goodness, okay, that's really stupid to me. 4, 4, 4, 16. Yeah, I wrote that down wrong. -9 over 4. 7 over 5. Yeah. Okay. I see that now.
Good.
Yep, got it.
Okay. So let's try a couple more. Okay. Very good.
Negative B over 2A?
2x squared plus 5x minus 3. Okay. So what you got on this one?
And so the H equals and then the K equals, that works for all equations, right?
Yeah, that's his formula. We just take
2.
now we got A is 2, B is 5, our C is -3. Yeah. And our template is this, y is equal to ax squared plus bx plus c. So that's why you can see that c is -3, because this is add c. So -3 is the same as adding -3. Why we got that.
Whoops. Sorry, I didn't mean to send that yet.
No, that's all right.
8.
Yeah, make sure the sign, okay?
Four.
Yeah, make sure the sign are good, okay?
Oh yeah, I messed up. All right. Fixed it. Wait a second. Okay. There. Is that correct?
Nope.
No. Okay. A times C. So that'd be 2 times
Well,
-3. That'd be -6.
minus our C is 1,
Minus
C is 5,
25.
and
That'd be.
2 times A is
Oh, that's 1/5. Okay.
-5/4. Okay, this sign is very important. We have a negative sign here.
Right. Okay. Oh, yeah.
Then we find the K. K is 4AC, 4 here. Our A is 2. Our C is -3. Then minus B squared. B is 5 squared. On the bottom, 4 times 2. So what we have?
-3. That'd be 6
2
times
times
4. That'd be
8 times -3.
that'd be negative.
24 minus
Negative 24.
5 over 8. So that gave us negative 49 over 8.
Yep.
Good?
Yeah. Good. Yeah, I realized I did it completely wrong.
Okay. Yeah, just make sure. I mean, making a mistake is not a problem as long as you know where and how you made the mistake.
Yep.
Oh, we got to learn. Okay. Let's do the last one. Yeah. Just make sure on the sign, okay?
Wait, did you write down the new equation?
Yep.
Oh, okay. Yeah, I wasn't paying attention. Sorry.
X minus
I see
5.
2 times.
have a question about K.
Mm-hmm.
So, when you're trying to solve H, it's
Yep.
when you're trying to solve H,
Four times 15. That would
I
be.
have the first bit, but it says you need to multiply 2 times A, which is 2 times -3.
Right.
But if the
And
question is already negative, then do I mark it as a positive?
Yep. Negative divided negative is positive. So we end up with this, right? -6 over -6. So negative over -6 has to be 1, right?
Yeah. Yeah. Thank you.
there. What about now?
Good job, Tammy. Yeah, simplify that. I'm sure you got them correct, but
Oh,
simplify that.
so
Like negative divided by negative is 1. Yeah, make sure the sign, because this is -6 over 2a. A is negative, so there's a negative and negative. We should have a positive. So that
what about now?
H is +1. Good?
Mhm.
Yeah, make sure you take care of the sign. Now, when we have K is 4, A is -3, our C is -5. The minus B squared, which is 6 squared, and over 4A. 4A is -3. Okay. Yeah, and then what we have? We got 4 times 5 is, first of all, negative times negative is positive. So 4 times 5 is 20, 20 times 3, so we got 60 minus 36. And then bottom is 12, -12. Now the top, we got 24, bottom -12, and that give us -2. So therefore, our vertex point is 1, comma, -2. Yeah. Good. Okay. Yeah. All right. I'll see you guys next week. Okay.
Thank you. See you
Thank
next.
you.
Bye.
See you next week.
Thank
Next
you.
week.
I'm glad I understand this.
Oh, wonderful. See ya.
See ya.